Welcome to another Math 65 lecture. This one is about the quadratic formula. If you haven't already, please go to YouTube and just look up some ways to memorize the quadratic formula. There are songs to either Pop Goes the Weasel or Row, Row, Row Your Boat. There are stories. There's a negative boy story, a negative B story. There's, I'm sure, other ways that I don't even know about. That this is a formula that we need memorized. It's called the quadratic formula. And the idea of this is if we want to set a quadratic equation equal to 0. So remember, quadratic just means that it's a polynomial of degree 2. So when we say quadratic, it means polynomial with degree 2, meaning x squared is the highest power. And we always want to set it equal to 0. That's going to be an important part of solving these problems. So the first step is always to make sure that you're setting it equal to 0. And then what this enables us to do is to find what x makes this equation true, no matter what a, b, and c are. So we just plug in the different values of a, b, and c that we get, and this will always tell us which x values make this equation true. So let's try it. Example 1, for the quadratic equation, 3x squared plus 5x minus 4 equals 0. What are the values of a, b, and c? So first thing to check is that it equals 0. Great, because you have to have that part. Then, to identify a is the coefficient on x squared. So in this case, a equals 3. And especially when you're first using the quadratic formula, it is good to write down explicitly what does a equal, what does b equal, what does c equal. It'll really help you plug into this formula. B is the coefficient on x. So in our case, b equals 5. And then c is the constant term, the term that doesn't have an x on it. In our case, c is negative 4. Notice that because this was minus 4, the c needs to be negative. It would be the same thing if the a or b were negative. That would need to be part of the formula when we plug in. So now it says use the quadratic formula. So let's first just write down the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in my head, I'm already like humming Pop Goes the Weasel or thinking of the negative b story. So hopefully you find a way that makes sense for you to memorize this. So now we're just going to plug in, and we're figuring out what x equals, and we plug in a, b, and c into this formula. It's a pretty complicated formula, but it's also a pretty powerful formula in that it doesn't matter what a, b, and c are, I can figure out what x makes this true. So notice the first one, sometimes I say negative b, but a good way to say this is actually opposite b. Because if b is negative, you would make it positive. So it's just the opposite sign of b. So in our case, negative 5. Plus or minus. This is going to give us two different answers. There's going to be a negative 5 plus a square root and a negative 5 minus a square root, which would give us two possible solutions. B squared. I would suggest squaring the number in your head, if possible. It just makes it a lot easier to type on the calculator. So just make it 5 squared is 25. I know that. Minus 4 times 3 times negative 4, 4ac, all over 2 times 3. At this point, we're going to need probably to use a calculator. I usually start with everything that's inside the square root. I'm going to just type that in. So turn it on. 25 minus 4 times 3 times 4. And then remember to make it negative, you got to use this symbol, not the minus sign. So it makes it negative 4 equals 73. Now you could have taken a lot more steps to get that, but just deal with what's under the square root first. Negative 5 plus or minus the square root of 73, and then 2 times 3 is just 6. The next step would be to look to see if there are any perfect squares that go into 73. I don't know of any, but you can always try a couple perfect squares. Hopefully we're good at simplifying square roots. So you could try 73 divided by 9, doesn't work. 73 divided by 16 doesn't work. I don't think there are perfect squares that go into 73. So that means that this is our final answer. Now, if we wanted to get an approximation, we could use the calculator to approximate this, but really our solution to this quadratic equation is either -5 plus the square root of 73 over 6 or -5 minus the square root of 73 over 6. Those are our two solutions. But let's get an approximation. When you're typing these on your calculator, you would need to view it as the top is separate from the divided by 6, because it's both the -5 and the square root of 73 that are getting divided by 6 in both of these. So what I typically do is just do the -5, so remember I have 5 and then I press the negative button, then plus 73 square root equals. So I just get the top part. And that would be 3.544 divided by 6. And then I can divide by 6 and say, oh, well, that's approximately 0.59. Then the other one, I'd type the 5 and then negative minus 73 square root equals. And that would be negative 13.544. And again, now we divide by 6 equals, and I get negative 2.26 approximately. So notice I'm using the squiggly lines for approximately. These are not going to be exact values. But what this is doing, so what we just found out, is that this parabola that we start with, so remember a quadratic equation gives a parabola. If I were to draw this parabola, the two places where it would equal 0, meaning cross the x-axis, are at 0.59, so just a little bit past 0, and at like negative 2.26. So that those are the two places. Now, this is not a great graph of a parabola by any means, and we're going to talk about graphing parabolas later, but I just want to give you a context of what these two numbers are. The other thing that they are, other than just the two places where the y value is 0, is if we plug these numbers back into the equation, it should give us 0. So that's one way you can check, is to do 3 times 0.59 squared plus 5 times 0.59 minus 4. So notice I'm just using the original equation and plugging in one of the x values that we got as our approximate solution. So let's just check that one, and I'll leave the negative one to you all to do on your own. But 3 times 0.59 squared plus 5 times 0.59 minus 4 equals. So the goal would be for this to equal 0. Because we rounded and we weren't using this exact value with the square root of 73, the calculator's not giving me exactly 0, but it's a number really, really close to 0, so that's good enough.